I would like to tell you a few things about embedding Python interpreter inside your C application. But before we start, I'd like to introduce myself. My name is Michał Gałka. I'm from Poland. I'm a software developer. I work in Harman. And apart from that, I deliver some training sessions for the Polish company called Sages. If you wish to contact me about this talk, about any other talk, or just to talk about anything, you may use whatever it's written on this slide. It will be repeated sometime at the end, so yeah, let's continue. So there are basically two things about C Python API. One is extending, second one is embedding. Extending is writing new functionalities for Python in C language. Embedding is about getting the Python interpreter and run it inside your C application, C or C++ application, so you can actually run the Python code from within your app. So why do you even bother about such a thing? Because, well, Python is just a very nice, simple language. Apart from that, it has a very rich standard library, so you can do a lot of stuff, not writing too many lines of code. And there are quite a few things that you can do in a much more readable, in a much more quicker way than in C. So, well, in a quicker means that you can develop them quicker, and they won't necessarily run quicker. But this is about theory. Let's talk about practice a bit. Oh, yeah, one thing that I forgot. And CPython already has the tools to get it embedded in your application. So, yeah, speaking about practice, this is the code that I took from a real-world application, not a very old one. This is how XML output is being generated from one of the tools I use quite often. The tool is Nmap. You probably know it is a port scanner. So Nmap, it is from the version 7.4, so not, which was released at the end of last year. So it is not an old code. So I bet you know how to generate XML in Python in a bit nicer way. So this was to convince you that it might be a good idea to have Python running inside Apex, and that let's try to figure out what we need to do to have Python running in our application and actually interact with our application. So we have the C application, and we need to get the Python interpreter run into. We need to take the data from our application, which will be probably in a slightly different format using different data types. And we need a Python script that we will read from the outside, import it into our application, and run. Okay? So all you need for that is Python.h. You need a header file. It is actually provided to you together with the Python interpreter. It might differ in different Linux distributions. On Ubuntu, all you need to do is just to do apt-get install Python 3-dev, or Python for Python 2. So we have the header. Let's write some code. So we include the header, and every time it starts with PyInitialize, it ends up with PyFinalize. Apart from that, we can deliver the program name. The program name is actually being used to configure the paths for the libraries. Okay? It's not necessarily it's not necessary to have it there, but we can have it, so I put it. So we put our important stuff between those two functions. So what do these two functions do actually? So PyInitialize, well, it initializes the interpreter, which is pretty obvious. Apart from that, it creates a few crucial modules like built-in, like main, like sys. It initializes the system path, and it initializes the table of loaded modules. The PyFinalize, well, it does quite the opposite. It just removes the interpreter, it removes all the sub-interpreters. Why do we want to do that? Not just leave the interpreter until the application ends. Well, imagine the situation in which you want to hunt some memory leaks. You want to get rid of the Python interpreter so you can focus on your main application. That's one of the reasons. There are probably some others that you may find during your job. What is crucial and what documentation says about it is that actually every object is being removed in a random order. So if you have like the magic del method in your object, it may get a bit haywire. You never know what it will do. It may try to delete the object that doesn't exist anymore. So yeah, let's embed something. So let's start. We have the PyInitialize, PyFinalize. We put the Python script into our C application. So we have like PyRun simple string. This is the most simplistic method to get Python running in your C application. However, the script won't be able to interact with your application. It's just running what you gave it. You can also use a PyRun simple file and provide it from the external file. But this is good for starters. We have it. Let's compile our application. For this presentation, I use the aforementioned nmap. So I put this code into nmap and try to compile it. So yeah, I ran the configure script, make, and it failed. So we're lacking the Python H. Well, I included the Python H, but the compiler doesn't know where it exists. So we probably need some options for the compiler, probably some difficult options for the compiler, but don't worry, help is at hand. There is a tool called Python config, or Python 3 config for Python 3, that will produce the appropriate flags, the appropriate options for the compiler and linker for you. So you have options like --c flags, --ld flags, --includes, and a few others. So yeah, the second attempt is like, yeah, we have the C flags, we have the LD flags for the linker, we have CPP flags because nmap is actually written in C++. So we run make, and it gets even worse. Because we have like a lot of undefined symbols. Why is that so? Because the compiler, when it tries to get the library, it doesn't find anything that uses its symbols. It will strip the symbols. So you need to include these libraries after you have mentioned something that uses the symbols from the library. So in this case, probably in other projects that are using configure scripts, you need the libs variable, and with the libs option. And then you can try to compile it, you can try to run it. And remember, do you remember what the code that we've included does? It was trying to print the platform it's running on. So yeah, it outputs something like that. So we've actually ran the Python code from the C application. Hooray. So let's try to put some data into our plugin module, and let's do something with the data. So imagine that you have the output from nmap. How many of you are familiar with nmap? Okay, so nmap actually scans the port of the IP that you gave it, and it will tell you you have this port's open, this port's closed, you have, it will print out like a report. So imagine that you can get this report, not in a form of an XML or the bare string output on your console, but in a form of a Python dictionary. Let's, for the sake of brevity, let's say that we have the Python data, which is the list of the list. So each list contains a dictionary which has information about the ports on the subsequent hosts. So if you give it like 2 IP addresses, you will supposed to get like 2 lists having the ports listed out. Like this is a TCP port, number 29. This is another TCP port. This is 5900, and so on. Yeah. So we'll try to produce this kind of dictionary in our C application, so you can process it in your Python script, okay? For example, let's have this Python script. This is a Python module. We call it nmap plugin. So the nmap plugin has the function inside. It's called process output. And let's try to convert the dictionary that we've just seen to JSON and save it into some file. In Python, it's just a few lines, probably a lot less that you do need to write in C. So how do you do it? So at first, what do we need to do? We need to convert the C types into something that's understandable for the Python interpreter. And we need to call the function, which is written in Python, from our C application. So let's start with the data conversion. Well, you will need the PyObject. The PyObject is like a very general structure that you will use all over the place. How does it look like? Well, these are just the snippets from the code that I wrote to actually make it running. So you may spot that you have a few things that are PyObjects, and then they get more specific when you initialize them. So you have like PyObject that's called hosts, but then you may see it as PyList new. So we create a Python list object with a length 0. So we've just created an empty list. Then we create the port list, so the internal list in our structure. And we call PyList append for each and every host we found on the network. So we append subsequent lists in our main list, so we can contain the data. And then for each port, we need to populate the dictionary. And the dictionary needs a key and a value. So we create a dictionary, so we have pydict new. You see the convention? It's more or less like that in the whole API. Then we need a few things. We need to list the protocol, so nmap knows what the protocol is, and it gives us as a string, so we need to make the PyUnicode object out of it. We need a Unicode object as we're programming Python 3. So we use this PyUnicode from string, so it takes the C string and creates the Unicode object. Then we set the string into the item of our dictionary. So you have like set item string. This is a simplified version. The more generic one can take any kind of key. The one I used is taking string as a key, just to simplify the most common tasks. And the other thing worth mentioning is the port ID. So we have like pylong from long. So we get the long type from C and we convert it to the long type in Python. That's how it is. So yeah, you remember this is our plugin. So if we want to use this plugin from a Python script, you would probably do something like this. Import nmap plugin, process output with some data. Yeah, if we were to call it from Python, it would have looked like this, but we need to run it from C, which gets a bit complicated. Let me highlight the most important things. Well, yeah, this was a bad joke. So yeah, let's do not bother about these things and maybe these things. So we create the Python module. So we need to create a string that actually is the module name, create a module. Later on, we create a function. We check if we have actually something on the output, because in most of the cases, Python C API will return null if the operation failed. So we need to check that. If it is not null, it means that we have an object. Yeah, like right here. And then we check if it is callable. If it exists and is callable, we have a function. So we have imported the module, we have imported the function, so we can call the function. So we call the function, and so we use the method called PyObject call object. We provide the method, the object that is callable, so our function object. And we need to provide the tuple, like the Python tuple, with the arguments. So how to create this tuple, I will tell you on the next slide, but there's one more thing that I remained highlighted. This is PyErrPrint. If something fails, you have a very easy method to display the Python error. Probably, if your Python script fails, you will see nothing more than segmentation fault, which is not very informative. You may have a look at this at the core dump, but sometimes it's just enough to print the error. And this is the function that does it for you. It's as easy as that, just PyErrPrint, nothing more. So how to create the tuple with the arguments? So again, this very same API is like PyTuple new, so we create a tuple. And we use the tuple set item. So we get the tuple object, the index at which we want to insert our object, and the object itself. In our case, it is hosts, which is the structure of data that I've shown you a few slides before, like the one that was called data. Okay? So this is actually the data we want to pass to our function. Okay, so we have the function. We have the possibility to call the function. So we call our function. And it worked. So I scanned my PC, on which I opened a few ports using netcat, just for the sake of the experiment. And it occurs that after running nmap, apart from excuse me, apart from the regular output, we have also a file created, which is called out.json, and we have a JSON inside. So we made it. So we have our function with a bit of code in C. So we have our Python function run from code in C, which is good. But remember that I have actually grayed out a few bits and pieces in the code that I've mentioned. Yeah? So let's talk about them. This is reference count. So in languages like C, the programmer is responsible for allocating and freeing the memory. And in this case, it is no different. So we do not use malloc and free, which are the functions in C that we use for allocation and deallocation of the memory blocks explicitly. But the Python has a mechanism that's called a reference count, just to automate the process a bit. So how does it work? Well, we have a Py object, or any other Python object. And each and every object has a reference counter. So whenever somebody is interested in this object, they call the PyIncref, which stands for Python increment reference. So it increments the reference count. It stores the reference to its object. So it says, I'm interested in this object. So please do not delete it. There might be a few of those. Elmo is here also. And when they are not interested in the object anymore, they are free to leave the reference. They call PyDecref, which decrements the reference counter. So yeah, now it is 2, it's 1, it's 0. And when it gets to 0, Python takes care about destroying the object. So Python itself doesn't actually call the free method explicitly. It just uses a function that is designed specifically for this kind of object. Like here, we have a specified deallocator for the cookie. So there are a few rules about it. So the first rule is that reference to an object can be owned. The object cannot be owned. So if we're talking about the reference counting, we talk about owning the reference to the object. Okay? The reference counter itself is just a number of owned reference to the particular object. And the owner of the object is responsible for running the PyDecref when it doesn't need the object anymore. There is also a concept, and you will see it in the documentation, like borrowing the reference. So the reference is not, well, if in Python, when you have the object created, for you, very often the function passes the reference to you. So you're responsible for calling the decref. Like I mentioned before, you're the owner, so you need to do the decref. When the reference is borrowed to you, then it's not your property. So as a borrower, you're not supposed to call the PyDecref, because this will do the owner. So you have it. You can use it, but you need to remember about one thing. You shouldn't use it longer than the owner actually exists, because the owner will call PyDecref, and you will start using the memory that has been already freed, which ends up with a very well-known communicate segmentation fault. So let's have a look at our code one more time, this time at the whole thing. So yeah, before that, can you see the PyDecref and PyIncref things? So I put one more thing here, which is the function output. But let's start from the very beginning. So we get the module name that we want to import. Then we import the module. Then we do not need the module name anymore. So it can be free. So we just decrement the reference counter. We don't need it anymore. Okay, so the PyUnicode created an object for us. It passed the reference to us, so we became the owner. And now it's our duty to say that we do not need it anymore. A bit below, like here, we have the increment of the reference. Why? Because we ran the function, we got the result, and we will probably want to return our Python function result to somebody else. So we can borrow him the reference. Call object will give. Call object will give me the increment one. Yeah, if it is increment. Yeah, if it is incremented, I shouldn't increment. That's true. For some reason, I thought it is borrowed. Not borrowed. It's not borrowed. It's unit. Okay. Sorry. So the incref is actually not needed. That is true. Yeah. So So in this case, the increment reference is not needed. And one more thing I wanted to tell you about is the xdecref. So it is a variant of Py reference decrement. This one will not fail if it gets null inside. Why don't you use it all the time? Well, because if you're sure that there should be an object, it's better that you see an error that something went wrong than just have it silent and face some consequences in a case, in a case you made a mistake. So in this case, it is the place where the function might not have been created. So we actually do not know if we will get null or the function object, but nonetheless, we want to get rid of this object. So we need to decrease the reference counter. So it's just better to reuse the xdecref than writing the next if statement. More or less like this. And now about calling our function. So creating the arguments for the function to call. And when we do not need this argument tuple anymore, and we do not need the when we do not need the output, we just decrement the references. And that will be actually all from my presentation for today.